Hello everyone. Welcome to our channel, the Digital Institute of Computing Technology. In this presentation we will have discussion on the topic sequence types and mapping types in Python programming language. Now, let us consider the operations that could be applied on sequence types and mapping types. What are sequence types and mapping types? Sequence types and mapping types are nothing but lists. Sequence types are a list of same type of single data items, whereas a mapping type is a list of a pair of data items, a key-value pair. So, whether it is sequence type or mapping type, both are list of data objects, whereas the sequence type has a single data object. Mapping type has a pair of data object. Now, let us see the various sequence types and mapping types supported in Python. List, dictionary, set and tuple. So, whenever we consider a list, what are the operations that comes to our mind? First of all, creating a list, then adding an element to a list, removing an element from a list, modifying a particular element in a list, searching a list, traversing a list. These are the main operations that could be performed on a list. To create an empty list, use list function or square brackets on the right-hand side of the expression as shown. To create an empty dictionary, use dict function or flower brackets on the right-hand side of the expression. To create an empty set, use set function on the right-hand side of the expression. To create an empty tuple, use tuple function or a brackets on the right-hand side of the expression. To add an element, use append, extend, insert functions for list, dict of, key, assigned value for dictionary, add, update, function for set. Tuples are immutable, so cannot add elements into tuple. To remove an element in list, use remove, pop, clear, functions, or del operator. To remove an element in dictionary, use pop, pop item, clear, functions, or del operator. To remove an element in set, use remove, pop, clear, and discard, functions. Tuples are immutable, so cannot remove elements from tuple. To search an element, can use in operator in all cases. Consider list LST with values 1, 2, 3. Here, 2 in LST is true but 5 in LST is false. 2 not in LST is also false. This way we can use in and not in operator to check the presence or absence of elements in list. Dictionary, set and tuple. To traverse, can use a for loop for all cases. For instance, to traverse the list LST with values 1, 2, 3, we can use for loop for item in LST, and can access the values using symbol item inside the body of the loop. Now, let us see some examples on how to perform these operations on a list. Let us assume we have a list LST with values 1, 2, 3. So, when print, it will be 1, 2, 3. If append 4, append will happen at the end of the list. So, the output will be 1, 2, 3, 4. Next, can extend one list with another list using the extend function. Have another list with values 5, 6. When do extension 1, 2, 3, 4 becomes 1, 2, 3, 4, 5, 6. Next, can insert an element into a list at a particular position. Let's insert a character, A, at position 2, and let's do it twice. So, at the position 2, we had 2. In its place, character A is placed. Next, insert operation will replace A by A. So, we have 2 A's. Finally, the list looks like 1, 2, A, 3, 4, 5. Now, let's see how to remove an element from list using remove function. can directly specify the name of the item to be removed and it will be removed. Call to remove will remove the first occurrence of A. We had two occurrences of A. The first occurrence has been removed. A pop function will remove the last element from list. So, 6 have been removed. Which was the last element? Pop of 3 in this case is an instruction to remove 3 from the list. So, 3 has been removed. Now the list contains 1, 2, A, 4, 5. We can modify a particular element in a list using index function. Example. List.index of 4 will give position of 4, which can be stored in variable I. Now, we know the position of 4, so we can modify 4 to 55. Now in place of 4, we have 55. We can delete an element from a list using a delete function. Delete list of A will delete A. So, element A has been deleted now. We can clear the list using list clear function. The list becomes empty. We can check the presence of an element in a list using an in operator. Say, if 55 in list, and want to modify 55 to 3. How we can do that? If 55 in list is true, we get the index of 55 using list.index of 55. Use that position as an index to list again and modify 55 to 3. This way we can modify an element in a list at a particular position. We can traverse the list using a for loop. For item in list print item, will print the entire list. So, this is how we can create a list. Add an element, remove an element, modify a particular element in the list, search an element in a list, check its presence, and traverse a list. Now, let us see dictionaries. So, this is a dictionary, a list of key-value pair. A is a key and 1 is a value. We have 3 pairs here. A1, B2, C3. Print dt of A is 1, because it will return the value associated with key A. There is another way to display the value. dt.get of B will output 2. But why this get function is used? In certain cases, when a key is not present, the dictionary will return an error. To avoid errors in such situations, we make use of get function to return a default value in case the key is not present in the dictionary. Next, we can modify an element. dt of D assigned 4 will add the key D to the dictionary, since D is not already present in the dictionary. We can modify the element by using dt of D assigned 20, so initially D was 2. Now it has been modified to 20. This way we can add or modify an element in a dictionary. Next, we can delete an element by specifying the name of the element. C has been deleted, with delete dt of C. So, when we print, we get A1, B20, D4, but C no more exist. We can pop an element. When we pop an element, it will return the value that has been popped. So, dt.pop A will return a value 1. Because key A had value 1. So, item was popped. The key is removed, but the value is returned. We can use that value if we want to do some processing. When we print, we get B20, B4. We can also delete element in the dictionary using a pop item function. It will delete the item and returns a key value pair, B20. Now, we have the dictionary with one item D4. We can clear a dictionary same way as we have cleared a list. It will empty the dictionary. How can we access the key value pairs in the dictionary? dt.keys will return all the keys. dt.values will return all the values. dt.items will return the key value pairs. We can traverse a dictionary by using this function. dt.keys, dt.values, and dt.items. If we want to traverse both key-value pairs, use dt.items. If we want to only process keys, then we can have for key in dt.keys. If we want to only process values, then we can have for values in dt.values. And we can access the values inside the for loop and process. So, this covers some important operations on dictionaries. Now, let's see sets. So, difference between a set and a list is that the elements in a set are unique and we can't modify an element of a set. We have a set here with values 1, 2, 3, 4, 5. We can add an element by using add function. We can remove an element using a remove function. So in this case, 6 is added, 3 is removed. Now we have 1, 2, 4, 5, 6. Now, let's assume we tried to modify an element in set. Say we want to change the value 3 at position 2 to 10. S1 of 2 assigned 10 will throw an error, as we cannot modify an element in a set, but this was possible in list and dictionary as we can see. All the operations in blue font are modifications in list and dictionary. We can perform union, intersection, and difference operations on the set. Let us assume we have another set S2 with values 3, 4, 5, 6, 7. So the set S1 has elements 1, 2, 4, 5, 6. The set S2 has elements 3, 4, 5, 6, 7. Then we can perform a union operation, an intersection operation, and a difference operation on this. This is useful in situations where real-world objects are sets and we want to perform some operations like union, intersection, difference, etc. on these real-world objects. The result of union operation is 1, 2, 3, 4, 5, 6, 7. The result of intersection operation is 4, 5, 6. The result of difference operation 1, 2. These are elements present in S1 but not in S2. We can check the presence of element in a set using the in operator same way as we did for list. We can traverse the set using for loop, same way as we did for list and dictionary. Here we saw how we can add an element, remove an element, perform set operations, check the presence of an element, etc. So, this is about sets. Now, let's see tuples. Tuples are similar to lists but they are immutable. The particular element in a tuple cannot be modified. Consider the tuple TPL with values 1, 2, 3, 4, 5. TPL of 2 we give us 3. But if we try to modify this element, we get an error. TPL of 2 assigned 10 will throw an error, as we cannot modify an element in a tuple. All the operations in blue font are modifications in list and dictionary. But in case of set and tuple, modify operations are invalid. Additionally, in tuple, we cannot add or remove an element, which is actually possible in set. We can check the count of elements in a tuple using a count function. We can get the index using an index function, etc. We can check the presence of element in a tuple using the in operator same way as we did for list. We can traverse the tuple using a for loop similar to the way we have traversed the list and dictionary. So, this covers an overview on some important operations on list, dictionary, set and tuple. Hope you enjoyed and liked the presentation. Remain connected with us by subscribing to this channel for latest updates on this channel. Thank you.